Hi guys, my name's Doug. Welcome to my messy garage. I'm going to have to admit something here. This project didn't quite work out the way I intended it to. There's still lots of good information in this video, but the 6-gauge wire that I used to run the battery back to the motor just wasn't big enough to provide enough current to turn the motor over. In a future video I'll show you the modification I made to get everything working, and I'm still going to leave the battery in the location that I installed it in this video, but just to let you know, this didn't work. Anyways, on to the rest of the video, and thanks for watching. Hi guys, my name's Doug. Welcome to my messy garage. Today's video we're going to be working on Project Pontoon boat. We're going to be relocating the battery from the tray that used to be right here up underneath the shiny new console that we installed in the last video. Follow along. Hopefully you find something useful. So under here we've got a nice little basic Group 27 battery tray screwed down to the floor of the console and through the console into the deck of the boat. We've got our Group 27 deep cycle battery that we've been using to start the boat with, and now we need to lift this thing up in there. Hope we can get this in here without pinching any hands. There we are, nicely strapped down with the Velcro hold down. Definitely you don't ever want to leave a battery unsecured in a piece of equipment that's going to be going down the road or bumping over waves on the lake. Now for the next step is stringing the battery wires that are going to go back to the outboard. Need some heavy duty copper crimp-on connectors. This one's not crimped on there yet, but we have 6-gauge cable. It is orange, which will be our positive, and black, which will be the negative. And this is a 25-foot box. Just happened to be the length of cable that was available, and that's what we're using. This looks like it'll spool out of that box quite nicely.
Recording.
We'll run this down through the floor, through the big hole that has the all the other electrical and the steering cable going through it. We're going to run it over to the top of the pontoon, down the top of the pontoon with the rest of the cabling, out of the top of the pontoon over to the motor and into the motor, where we're going to install it onto the starter solenoid. That's good enough to start. I'm going to go underneath and feed it along. These are the original battery cables that came on the boat. I think you can kind of understand my desire to upgrade. So one thing we want to do with this is leave a little bit of a service loop. That way, if anything needs to get changed slightly in the future, but there is a fair amount of slack. Got some nice heavy cutter crimpers. That looks pretty good. So this end is not big enough to go over the battery terminal. These ends are a little on the large side, but I think they'll be okay. And for stripping this off, rather than using a wire stripper that simply cuts in and pulls, I'm going to use a utility knife strictly so that I can kind of control how deep the cut goes. I don't want to go deep enough to cut any of the strands. There's one strand cut. Hopefully that's all we get. So after a little bit of drama finding the heat gun in my, shall we say, messy garage, we're going to put some heat shrink on to cover, well, those aren't the ones we're going to use. This is the one we're going to use. Cover most of the terminal. It limits the amount of exposed bare metal around the battery so that if something falls down, it's less likely to cause an unintentional short. And you always have to remember to put the heat shrink on first. There are some instances where you can get it on afterwards, but those are few and far between. Now we break out the fancy crimper. This is a hydraulic crimper. I got it from Amazon. I'll throw a non-affiliated link down in the description, I guess. Basically, it works with a little hydraulic pump. Squashes the terminal. And then when you're crimped, open it back up again. I believe that this is the right size for this size of terminal. It says 10 on there, but something tells me that's not American wire gauge. I believe that is some kind of metric designation. So we're all the way seated down, a little bit of slack there, but not a whole lot, and that'll get covered with the heat shrink, and then we just pump this up. Helps if you close the valve. And there we have a nice solidly crimped terminal. Now take the heater, we'll put this on high because we're outside and there's a little bit of a breeze. Now inevitably there will be the question, can you heat shrink with a hairdryer? And the answer generally is no. Hairdryer doesn't put out quite enough heat. This gun came in a kit with a bunch of paint stripping accessories. Now we will rinse and repeat. Some people like to solder these connections. The problem that you get into when you solder a stranded connection like this is that where the solder ends tends to create a stress riser, and you'll actually crack the wire off at the end of the solder. So a good solidly crimped connection like how this one was done with a hydraulic crimper is a far better joint than if I had filled that with solder and melted it together. So the heat shrink tubing we're using here looks like normal heat shrink. It's not quite as heavy as the double wall marine stuff that I've seen before, but this does actually have, I don't know whether the camera will pick it up in there or not, but it does appear to have a layer of glue on the inside of the heat shrink, and what that does when it heats up and shrinks, the glue melts to the inside surface and you get a relatively watertight seal. And here's the crimping kit. You can see there's several different sizes of anvils, down from little tiny ones all the way up to quite large. And I forget what I paid for this. I've had it for a few years, but I don't think it was well under $100. Anyways, I'm thinking it was around $50 if I remember correctly, and I've used it several times. Okay, we're ready to do the wiring on the motor end now. Lift the hood off the old Force. The electrical is down here. We need to take the positive lead off of the solenoid and the negative lead, which I can't see where it attaches, but it's in there somewhere, so I'm sure you can in the camera. Replace the battery cable going into the motor. I have to be honest, those two fasteners were not terribly tight. Something tells me I'm going to have to cut that terminal off of there. Which is all right. These old battery cables are pretty much rotten anyways. The opening in the front of this motor is somewhat a little on the snug side. Getting these cables up through here. Something tells me the cables we're fighting with here are possibly not the original size. The first 4 inches or so went quite nicely, but now it's being difficult. While I've got some stuff torn apart here, I've kind of come across some rather questionable wiring. The main power lead going to the power trim, and the green wire for the power trim looks like it's been a little on the warm side. Now the motor was seized on the power trim unit, so probably there's been some pretty heavy duty power going through these wires. I think what we're going to have to do is pull a little bit of this power trim wire back into the motor, and I think we're going to have to clean up some of this wiring. Electrical tape over something. Feels like there's a splice of some sort in there. Boy, am I ever glad I took that apart. Note to anybody that's doing any kind of electrical work in a boat, twisting the wires together and putting some electrical tape on it is not a proper way to do a splice. I don't want to get too carried away pulling this power trim cable through, because there's enough, but there's not a huge amount of slack. So we're pulling the third wire apart. Yeah, of the 3, one had a pretty disgusting looking butt splice in there. The rest of them were twisted together. I think what we're going to end up doing here is cutting back to some good clean wire, and we're going to put some nice heat shrink splices on there, and we're going to get rid of this damaged wire here. Sometimes it pays to look closely at these kinds of things. So I stripped off the ends of these wires and the copper wasn't good and clean, so I had to take another inch or so off. Well, hopefully that'll be enough to get us back to some good clean wire. I'm going to grab some Scotch-Brite and give those just a little polish. Now, interestingly enough, what looks like corrosion on this wire is green. The same stuff that's on this one, on the blue wire, is blue. So I'm wondering if that might just be a little bit of residue from the insulation. Anyways, the Scotch-Brite brought it down, nice clean copper. I think that will work quite nicely. So what we have here is some nice crimp-on terminals that have heat shrink built into them. So like a normal red colored crimp-on connector, but you'll notice that the red comes back quite a bit further. This piece is heat shrink, and after you crimp it in place, hit it with a little bit of heat, it shrinks down in place and provides a nice seal. I prefer to use a ratcheting crimper. The way these ratcheting crimpers work is you'll notice that they won't open back up until you've completely crimped hard enough to crimp the wire. I use these in aviation, but they also work well in standard connectors. Now, one problem we're going to have here is that the wires that run up to the front of the boat are considerably heavier gauge than this wire is. And to get a good crimp on these small wires, basically we're going to have to fold them over like that and crimp against the insulation. That is not ideal. I completely admit that that's not the ideal way of doing this, but I don't think we're going to get a good crimp on it if we do it any other way. So this ring terminal is what's going to provide power to the trim system. It comes off of the battery terminal for the on the starter solenoid. There, just a little crimp on that one. I see some burned off or corroded off ground wires down there, but it appears that that wire has been replaced with this loop here. Doesn't look like it's too bad a shape. Cut that. Cut the corroded stuff out of there. Now our lead for the to provide power trim goes on. And our positive lead runs to the battery is next. Spacer blocks in for the relays, and we put the relays back in. Okay, that looks not too terrible. Much better than it did before anyways. That should be able to bring power back from the battery to the motor. We've got some more terminating to do under the cowl. I'm going to grab that before the wind grabs it and knocks it on the ground and spreads it all over the place. I think the wiring that we've got to do under the cowl here, for the most part, is pretty much done. Except for the trim motor, but that's going to be in the next video. I think we're going to end it there, guys. As I said at the beginning of the video, this didn't quite work out the way I had intended it to. However, the modification I came up with is actually going to make it a much better setup. We're going to end up with a dual battery and have lots of juice for running accessories. Anyways, I will show that to you in a future video, and appreciate you stopping by to check this one out. Thanks for watching.